In this video, I want to talk about statement logic. Now, statement logic is a formal system that's covered in pretty much every intro to logic course that one can take in college. And probably the first thing worth saying about it is that you might know it by a number of different names. So some will call it statement logic, some will call it sentence logic, others will call it propositional logic. I myself might jump between some of those names because they all just refer to the same system. In any case, statement logic is just a formal system, which means that it's a symbolic system, right? And it serves the purpose of representing the inferential connections of natural language. Now, if you want to know more about what the purpose of formal systems is, I have a video that I've uploaded on that you should check out. But in any case, in this video, the main thing that I want to focus on is just the vocabulary of statement logic, and specifically what the symbols of statement logic represent in natural language. And that means that the best place to start is by saying a couple of things about natural language, just so we get some definitions down and know what we're talking about. So statements in natural language, and you'll remember that a statement is just any sentence that's either true or false. Statements in natural language can be divided into two categories. You have atomic statements and compound statements. Atomic statements are statements that contain no logical operators. And I'll say something in just a few seconds about what logical operators are. But atomic statements don't contain any, and compound statements will contain at least one logical operator. Okay, so what's a logical operator? Logical operators are special words in natural language that perform logical functions, right? The details don't matter right now. What matters is just that you know which words in English are the logical operators, and just a sort of brief overview of what they do. So let's just start off with the words, right? So here are the operators: not, and, or, if, then, and if, and only if. 4 of these will be very familiar to you. It's possible that this is your first time encountering the logical operator if and only if. I'll go in depth. I'm going to provide videos on each and every one of these independently, just talking about how they're represented and what they do. But in broad strokes, these words serve to modify the truth values of atomic statements, right? And they can also modify the truth values of compound statements. So here's a really basic example. Here's an atomic statement. The sky is blue. Notice it doesn't contain any of these words, right? Now, the sky is blue is a true proposition. If I add a logical operator to it, like not, right, then that turns into the sky is not blue. And that proposition turns out to be false. So the operator not can take the truth value of the atomic statement, the sky is blue, and modify it, right, to make it false. And realize that this also works with compound statements. So now take the compound statement, the sky is not blue, add another not on there, right? So the sky is not blue, and now it's back to true. Of course, now you've got a redundant double negation in there. But you get the point. I'll be providing very in-depth videos over exactly how it is that these things work. But these are the 5 logical connectives, and atomic statements don't contain any of them, whereas compound statements do contain logical connectives, operators, what have you. Okay, so now let's go ahead and start talking about the symbols of statement logic. And this is going to comprise the vocabulary of statement logic, right? So these are the words, and they form the sentences of statement logic, and then I think that the scare quotes will become apparent as we move through this set of videos. Okay, so first, I've just laid out a couple of things here. Let's focus on where I've written the word statement, right? So part of the vocabulary of statement logic is going to be all of the capital letters A through Z, right? So A, B, C, D, E, all the way through Z, all of those capital letters are going to be, let's say, correct letters that one can use in statement logic. The lowercase letters don't count, letters of other alphabets don't count, right? Only the capital letters A through Z get to do anything in statement logic. And what these letters do is represent statements. So, for instance, if you have a statement in natural language like the sky is blue, you might write this in statement logic as just the capital letter B. which letter you use to represent which statement in natural language, in our case in English, doesn't matter. However, it is a best practice that you use a letter that clearly stands for something in that sentence. And that's just for your own sake, because in your classes, you're probably going to be asked to symbolize sentences, paragraphs, so on and so forth. And it'll be more useful for you if you can track which statement letter represents which sentence. So I've chosen B for blue, but I could have just as easily chosen S, and that would be an equally all right choice. Right? It's up to you, whatever is easiest to track. Notice it'll be much harder to track if you just use A, B, C, D, E, F in that order, right? Because then you might not know which letter stands for which sentence. Okay, so you have the capital letters A through Z. You also have 5 symbols for the logical connectives. So I'm going to write down some of these symbols and then I'll say something about it. So not tends to be represented by the tilde, and is often represented by the dot, or is represented by the lowercase v. If then is often represented by an arrow, and if and only if is often represented by a double-headed arrow. These are my preferred connectives. These are my preferred symbols for the logical operator. So if I'm going to write or in statement logic, I'm going to write it with the lowercase v. But this varies from class to class, and some professors are huge sticklers about which symbols you're allowed to use. So make sure you stick to their conventions. I'm going to offer you just a few more symbols so you can see how much variation there is here. For instance, for not, sometimes this symbol is used instead. And has the ampersand that's used sometimes, or sometimes the caret, right? The upwards facing caret. Or I don't think I've ever seen in any other way than just the lowercase v. If then is sometimes represented by what's called the horseshoe, and if and only if is oftentimes represented by what's called the tribar. Your professors might pick any single combination of these. Stick to whatever it is that they tell you to do. My personal favorite, and I'll mark it in red, is these symbols. For no other reason than the fact that that's just how I learned how to write these. Okay, so in statement logic, you have the capital letters A through Z to represent statements, and you have the tilde, dot, V, arrow, and double-headed arrow to represent, respectively, the logical operators not, and, or, if then, if and only if. Finally, statement logic gives you access to parentheses, and it gives you access to all of them, right? So these parentheses count, the square brackets count, and the curly brackets count. And the function of these brackets is to avoid ambiguity. And I'm going to show you exactly how that works in just a second. But this is the entirety of the vocabulary of statement logic. So when you're writing in statement logic, these are the only symbols that you are allowed to use. You can write statements using only capital letters, logical connectives, and parentheses. Furthermore, statement logic has certain rules of grammar, right, that make what are called well-formed formulas. We will cover that in a later video. I think it might be the next one that I upload, but I'm not sure. I have to check my upload schedule. But there are rules about how you can arrange these symbols in a way that's correct and in a way that's not. We'll worry about that later. For now, what matters is just make sure that when you're writing propositions, statements in statement logic, you use only these sets of symbols. All right, so let's consider an example. We're just going to symbolize this statement. Okay, so the statement reads, if it's raining, then I'll stay home and eat pizza, which sounds like an absolutely wonderful thing to do when it's raining. So first and foremost, what I'm going to do is I'm going to attribute to every atomic statement that's in this compound statement a statement letter. So for instance, for it's raining, I think I'm just going to use the capital letter R. I could have used anything. I could have used the letter A, the letter G, whatever. R makes it much easier for me to track which statement I'm representing with that letter. I'll use S for I'll stay home. And I'll use E for I'll eat pizza. And every single statement letter must represent an atomic statement. Okay, so every statement letter represents a statement that has no logical connectives because you have access to the logical connectives. So you already have symbols that can represent those. So every statement letter represents an atomic statement. R in this sentence represents it's raining. S represents I'll stay home. And E represents I'll eat pizza. Now, the compound statement, the one that I'm trying to represent, states if then, right? If it's raining, then something will happen. Right? And furthermore, the thing that's going to happen is two things. I'm going to stay home and I'm going to eat pizza. That would be represented like this. So if it's raining, then, right? So we have our arrow connecting the raining to what follows next. And what's going to follow is two things. Both of those things will follow from it raining. We can just tell that by reading the sentence, right? So I'm going to use parentheses to group these together. I will stay home and I will eat pizza. So if it is raining, then I will stay home and I will eat pizza. The parentheses are located where they are because that is the most accurate, in fact, that's the fully accurate representation of this example sentence. This is correct. This would be incorrect, right? What this represents is if it's raining, then I'll stay home. Furthermore, regardless of whatever else happens, I am going to eat pizza, right? And that's just not what the original sentence was expressing. The original sentence sets raining as a condition for both of those things happening. So you need to make sure that when you translate this, you accurately translate what's being expressed logically in your, whatever it is that you're translating. In fact, translating isn't even really the right word. It's transcribing, but that's not an issue we need to get into here. Okay, so overview. Statement logic, right? It's a formal system and it has a vocabulary. And in this video, all we've done is cover that vocabulary. We haven't covered anything else. That vocabulary is comprised of three separate things. One, capital letters. Those capital letters stand for statements. Two, the 5 logical connectives, right? So you've got the tilde, the dot, the lowercase v, the arrow, and the double-headed arrow, and those respectively stand for the logical connectives. Not, and, or, if, and if and only if, right? And finally, you have access to parentheses, and parentheses serve to ensure that you have no ambiguity in your statements. In fact, I'll write one last way that a student might symbolize this that would be incorrect. Notice I have not used any parentheses here. I've just written if, are, then, s, and e. And this is ambiguous because it's not clear whether it's stating this or whether it's stating this up here. And you need to make sure that none of your sentences in sentence logic are ambiguous, ever, right? You always need to make sure that your parentheses disambiguate everything so that you always know what's going on. And we will talk in a later video about exactly how to make sure of that by making sure that everything that we write in statement logic is well formed, right? That it follows the grammatical rules of statement logic. But in any case, I think that's enough for one video. We've gone a little bit over than I would have preferred. So if you want to learn more about statement logic more generally, and at some point I'll upload general philosophy videos, then be sure to stick around. I'll hopefully see you next time.